Welcome back to Code and Conquer Daily, where we solve a new LeetCode problem every single day. If this helps you out, please hit the like button, share it with a friend, and subscribe so you never miss tomorrow's solution. Today we're tackling problem number 1406, Stone Game 3. LeetCode problem number 1406, Stone Game 3. Alice and Bob continue their games with piles of stones. There are several stones arranged in a row, and each stone has an associated value which is an integer given in the array stoneValue. Alice and Bob take turns, with Alice starting first. On each player's turn, the player can take 1, 2, or 3 stones from the first remaining stones in the row. The score of each player is the sum of the values of the stones taken. The score of each player is 0 initially. The objective of the game is to end with the highest score, and the winner is the player with the highest score, and there could be a tie. The game continues until all the stones have been taken. Assume Alice and Bob play optimally. Return Alice if Alice will win, Bob if Bob will win, or tie if they will end the game with the same score. For example, given stoneValue equals 1, 2, 3, 7, the expected output is Bob. To solve this problem using a brute force approach, we would need to simulate all possible moves for Alice and Bob, and then determine the winner based on the final scores. However, this approach would be very inefficient, as the number of possible moves grows exponentially with the number of stones. For example, if there are 10 stones, there are over 500,000 possible moves for Alice and Bob to make. This approach would have a time complexity of n to the power of 3, where n is the number of stones, making it impractical for large inputs. The complexity here is n cubed. The optimal solution involves using dynamic programming to store the maximum score Alice can get for each possible number of stones remaining. We can then use this information to determine the winner of the game. The key insight is that Alice's best move is to take the number of stones that leaves Bob with the minimum possible score. By using dynamic programming, we can efficiently compute the maximum score Alice can get for each possible number of stones remaining, and then use this information to determine the winner. The complexity here is n. Now let's implement the optimal solution in C++. I'll write it out step by step so you can follow along. Thanks so much for watching. If this helped, give the video a like, share it with someone who's learning, subscribe to the channel, and ring the bell so you never miss tomorrow's LeetCode solution. See you in the next one.